In section 2.1, we're talking about factors and prime numbers. Let's talk about factors first. Factors. If you remember from chapter 1, we had an example that looked like this. 3 times 4 equals 12. We call the 3 what? Factor. We call the 4 what? Factor. And we call the 12 anyone? Product. Yep. That was in chapter 1. So when we give you a problem, it says list all the factors of 12. List all the factors of 12. Well, how do you get 12? Well, I can get 12 by going what? 1 times 12. Isn't that a 12? What else? 2 times what? 6. Isn't that a 12? 3 times 4. Is that a 12? Anything else? So when we say list all the factors 12s, we're talking about these numbers because these are factors. So the answer, I like to put them in order from small to large. 1, comma, 2, comma, 3, comma, 4, 6, and 12. These are all the factors of 12. Can everyone see that? Is it clear? In the back? I can make it bigger if you can't see it. Let's try another one. List all the factors of 36. So let's list all the factors of 36. How do you get 36? 1 times 36 is 36. Good. That's 2 of them. 1 and 36. What else? 6 times 6 is 36. That's good. What else? 2 times 18 is 36. Good. What else? There's more. 4 times 9. Good. Is 36. One more. 3 times what? Nope, 2 times 18 is 36. 3 times 12, right? That's also 36. And I think that's all of them. So when you list all the factors of 36 from small to large, 1, 2, 3, 4, 6, 9, 12, 18, and 36. So that's what the factors, finding the factors of a number. Now, the order that you write them really doesn't matter mathematically, but I'm sure the software wants them from small to large. So make sure you put them in order from small to large. Otherwise, they're probably going to mark it wrong. The reason actually they do that, because if you put them in any order, then they have to list all the possible answers, and there'll be about 20 different choices for an answer to write them different order. And they're not going to type all that stuff, so they'll make you put them from small to large. This way they only have to put one answer. The next topic in this section is prime numbers. Finding the prime numbers and prime factorizations. Well, before we get to prime factorization, let's talk about prime numbers. So let's see. What are prime numbers? In our book, there's a definition of prime number. A prime number I can highlight that in yellow, is a whole number that has exactly two different factors, itself and 1. See that? And the other one, a composite number, is a whole number that has more than two factors. Other way of saying it, translation. What are prime numbers? Any whole number. Whole numbers are what? 0, 1, 2, 3, 4, 5. These are whole numbers, but it says any whole number that has exactly two factors. So another way of saying it's any number, any whole number, but it has to be larger than 1. 1 is not a prime number. Any whole number larger than 1 that is divisible. You can divide it by 1 and by itself. By 1 by itself. That's it. So let's take a list here. Prime. Any whole number larger than 1. Well, let's begin with the list. Is 2. Is 2 a prime number? Can you divide the 2 by anything except 1 and by 2? No. 2 is a prime number. How about 3? Is 3 a prime number? Yes, you can't divide 3 by anything except 1 and 3. Is 4 a prime number? No. Why? Because you can divide 4 by what? By 2. So 4 is not. I'm putting the not down on the bottom. How about 5? Yes, you can't divide the 5. How about 6? No, you can divide it by 2 and by 3. How about 7? How about 8? No. 9? No, you can divide it by 3, right? 10? No, you can divide it by 2 and by 5. 11? Yes. Can't divide 11 by anything except 11 and 1. 12? No. You can divide it by 2, by 6, by 3, by 4. 13? Yes. 14? Bless you. No. You can divide it by 2 and by 7. 15? I can divide the 15 by 5 and 3, so it's not a prime. 16? I can divide it by 2. It's not a prime. 17? 18? 19? Yes, you can't divide 19. 20? 21? You can divide 21 by what? By 3, by 7. 22? No. 23? Yes. And I think you get the idea. Now, if the number is not a prime number, then what do we call these numbers? Composite numbers. So basically, composite is not a prime number. Any whole number that has more than 2 factors. This has more than 2. It has 1, 2, and 4. 1 times 4 is 4. 2 times 2 is 4. There's the 1, the 2, and the 4. There's 3 factors. 6 is 1 times 6 and 2 times 3. There's 4 factors to that one. So if it's not a prime number, it's a composite number. Okay, why are we interested in that? Well, because the next topic for us is prime factorizations. So, what's prime factorizations? Prime factorizations. Let's say I gave you the number 12. I says, can you tell me, can you rewrite 12 as some kind of a multiplication of some numbers, but use only prime numbers? Use only prime numbers. I go, well, 12 3 times 4. Well, there's a problem. Is 4 a prime number? That's not good. 3 is a prime number, but not 4. 12, we go, well, that's 2 times 6. I go, well, 2 is a prime number, 6 is not. 12. 1 times 12. Neither 1 is a prime number. 1 is not a prime number. 12 is not a prime number. But I want to write 12 as the multiplication of some prime numbers. Only prime numbers. That's what prime factorizations is. How about 12 equals 3 times 2 times 2? What 3 times 2? 6 times 2? Are these all prime numbers? So that's what a prime factorization is. The question is, how do we come up with that answer? I mean, that's an easy example, the 12, but what about when the numbers get bigger? So we do have a method to get you there. So let's look at that and see how we're going to do it. The method of finding prime factorization, we take the 12. We said to you, don't use 1 and 12. Any other ones are fine. Give me two numbers. If you multiply them out, the result is 12. It doesn't matter if they're prime or not. Just don't use 1 times 12 because that's silly. It doesn't help me here. What two numbers, if you multiply them, the answer is 12? What is it? 6 times what? 6 times 2? Okay. Is 2 a prime number? Yep. That's a keeper. Is 6 a prime number? No. Can we take the 6 now and break it down? 6 is what? 3 times 2? Are these prime numbers? Yes. So the 6 is gone now. I'm replacing the 6. Replace the 12 with 6 times 2. So when you look at it, the 12, actually, what's left on the bottom? I like to put them from small to large. I see 2 2s and 1 3. 2 times 2 times 3. That's 12. That's all prime numbers. If you want to write that in exponential form, that's what? 2 squared times 3. They're probably going to be looking for the answer in this form, but I'm laying the foundation for the next section, the next topic. That's why I'm using that form. I have a plan. Let's try another one. 36. I want the prime factorizations of 36. Again, the first two numbers that comes to your mind, that'll give me 36 if you multiply them. 6 times 6. Okay. So I'm going to take the 36, replace it with 6 times 6. Is 6 a prime number? No. 6 is what? 2 times 3. Are these prime numbers? Yes. The 6 is gone. And let's look at that 6. Replace it with what? 2 times 3. The other 6 is gone. Now what you have left, I circle them all prime numbers. So 36 is equal to what? 2 times 2 times what? 3 times 3. Yep. How many 2's? 2 of them. How many 3's? 2 of them. That's the prime factorizations of 36. What prime numbers, if you multiply them, because it has to be multiplication, that's why it's called factor, prime factorization, multiplication. What prime numbers, if you multiply them, the answer is 36. Okay, let's have you try one. Ready? You give it a try. I'll give you a couple of minutes to think about it. 72. Think of any two numbers. If you multiply them, the answer is 72, and start breaking them down using prime numbers after that. How many of you started with 9 times 8? Yep, a lot of you. Anyone start with 36 times 2? Yep, there's a few of you. Anyone start with 3 times 24? Good, I'll do 3 times 24. The point I'm trying to make, it doesn't matter what you start with. You can start with 9 times 8. You can start with 2 times 38. I can start with 3 times 24. At the end, my answer, your answer should be the same. Is the 3 a prime number? Yes. Is 24 a prime number? No. So the 24 is going to go away. It's going to be replaced with what? 8 times 3? I could have went 6 times 4, 8 times 3. It doesn't matter. Is 3 a prime number? Yes. Is 8 a prime number? Nope. 8 can be replaced with what? 2 times 4. Is 2 a prime number? Yes. Is 4 a prime number? No. 4 can be replaced with what? 2 times 2. Are they prime numbers? So 72 is going to be, let's look and see how many 2's we see there. How many do you see? 3 of them. And how many 3's? 2. So it's 2 to the third times 3 to the second. One more to try it. 80. I'm guessing probably most of you use 8 times 10, huh? Yep. You could use 20 times 4, 16 times 5, doesn't matter. Is 8 a prime number? No. 2 times 4. 2 is a prime number. Is 4 a prime number? No. 2 times 2. Let's look at the 10. It's not a prime number because you can divide it by 2. 10 is what? 2 times 5. And now these are prime numbers. So the 80 is going to be what? Let's see how many 2's I see there. I see 4 of them. And 1 5, right? So it's 2 to the fourth times the 5. Yes?
When writing out the equation, does it matter what order you place the numbers?
Nope.
You can put the 5 before the 2?
You can, but I'm sure our software probably likes the smaller number first, the larger number last. But mathematically, no. Okay. The next topic in this section, some of you, when I took you to take that pre-test to see if you belong in Algebra 1, they asked you to find the LCM. And some of you came to me and said, I don't even know what the LCM means. So here's this one, the least common multiple. Now let's look at the word multiple. Let's discuss that word first. Multiples. If I said to you, before I answer this question, the least common multiple, by the way, we call that LCM. That's abbreviation for it. We don't want to write least common multiple. That's too much writing. Just like on the phone now, see you tomorrow. You put the letter C, the U, because you don't want to write CU, you know, the whole thing. The same thing in math. We're always looking for a shortcut. So now multiples. If I said to you, give me the first 4 multiples of 5. What are the first 4 multiples of 5? Remember, multiples. What's 5 times 1? 5. What's 5 times 2? 10. What's 5 times 3? 15. What's 5 times 4? So here are the answers. What are the first 4 multiples of 5? 5, 10, 15, and 20. So multiples. It's not factors, it's multiples. So the smallest number is always the number itself, then the rest of them will be larger. Where the factors, everything is less than the number except one number. Find the least common multiple of 12 and 9. I should have wrote the word and here. We're just lazy. Try to fix it, made it worse. Find the least common multiple of 12 and 9. Let's begin with the 9. Let's write some of the multiples of 9. What's 9 times 1? 9. What's 9 times 2? 18. What's 9 times 3? 27. What's 9 times 4? 36. What's 9 times 5? 45. We'll stop here to see if we have an answer. Let's take the 12 now. What's 12 times 1? 12. What's 12 times 2? 24. What's 12 times 3? What's 12 times 4? Let's stop right here. What is the first number that's in both of these sets that you see? 36 is the least common multiple. That's the first number that you see in both groups. This is not the best way to do it. In this example, it's not bad. In other example, this is horrible, doing it this way. So what's another way of doing it? I'm going to redo the same problem now differently. The way I'm going to do it is using prime factorizations. Let's look at the 12. Break the 12 down. What do you have? 2 and 6? Okay, 2 is a prime number, 6 is not. Take the 6, break it down. 2 and 3, yep. So the 12, what do you notice? How many 2's? 2 2's and how many 3's? 1. I like to put them in a box. This way when I'm looking for them, I can spot them quickly. Let's look at the 9. How do you get 9?
3 and 3.
Are they prime numbers?
Yep.
Yes. The 9 is 3 squared. Put them in a box. Got both of them. Done. Now, what is the LCM, the least common multiple? It's the multiplications of, it's a big definition, all the different factors, each of them is raised to its highest power. The multiplications of all the different factors, each of them is raised to its highest power. I guess I didn't save much writing by abbreviating multiplication to mult. I could write multiplications. So let's see what we have for an answer. LCM. Look inside the 2 boxes. Don't worry about the power first. What do you see for numbers, the bases? What do you see in them? 2 and the 3, right?
Yep.
So it's 2 times 3. You multiply them, the different factors. I see a 2, a 3, and a 3. So there's only 2 different ones, 2 and 3. Each of them raised to its highest power. When we say each, we don't combine the power. We look at each box separate. What is the highest power of 2 that you see here? 2. And what is the highest power of 3? 2. Don't add this to that. Look at them individually. This has a power of 1. This has a power of 2. Which one is bigger?
2.
The 2. And now let's find out what that answer is. This is from last class, order of operations. You got to do the exponents first. What is 2 squared? 4. What's 3 squared? 9. What's 4 times 9? 36. For this example, going, well, that's a long way of doing it. Well, you know what? If I gave you the next example, I'll pick another one. Find the LCM of 20 and 21. Let's look at 20. And here's the 21. Prime factorization. 20 is what? 4 times 5? 2 times 10? Doesn't matter. 5 is a prime number. 4 is not. 2 times 2. We have 2 2's and 1 5. What about 21?
7 and 3. Give me 7.
3 times 7. Are they prime numbers?
Yep.
Yes. 1, 3, 1, 7. Ready for this? The LCM. It's the multiplications of all the different factors. Let's look in the boxes. Tell me what you see for different factors. I see a 2. I see a 3. I see a 5. I see a 7. What is the highest power of 2?
2.
2. What's the highest power of 3?
3.
How about a 1? There's no power to it.
Yes, 1.
What's the highest power of 5? 1. What's the highest power of 7? 1. So let's find the answer to this. What's 2 squared? 4 times 3 times 5 times 7. 4 times 3. 12 times 5 times 7. What's 12 times 5? 60 times 7. Guess what the answer is? 420. Now, just to give you an idea, if you decide to do it the other way by listing the multiples. Ready for this? Watch this. Let's take the 20. What's 20 times 1? 20. What's 20 times 2? 40. 20 times 3? 60. 80. 100. 120. 140. 160. 180. 200. 220. 240. 260. You still need another page just to get to the 420. So that you could be there for half an hour listing all these numbers to get to the 420. Then you got to do the 21 to see where the match is. So really, doing this way, it's not the best way to go. This is the better way to do it. And if you have 3 numbers, it doesn't change. I could give you 3 numbers, 2 numbers, the process is exactly the same.